Hello, Neuromar here, and I'm back to talk about 6 more power inverters. Last time I'd covered 6 inverters from this little 400 watt jobby to this 1500 watt inverter from Xantrex. And these are all lower power inverters. Today we're going to be talking about inverters that are greater than 1500 watts, and I have 6 to show you. Now, one thing I do want to mention about these higher power inverters is that you will not be able to get their rated power out of a single battery. You'll need a bank of batteries, at least 2. Typically a battery, a portable style battery, and I'll just define portable as group size 27 and below. A group size 27 battery weighs about 60 pounds. Anything too much heavier, you're really not going to be carrying it around. You only get about 1000 watts out of a battery. So if you have a 5000 watt inverter, you're probably going to need 5 batteries in parallel. And that's a lot of batteries, more than what's practical for a lot of applications. So just keep in mind with a 12 volt inverter, which is all that I'm covering in these 2 sets of videos, you will need a very good power system with very thick cables as well. Now for something like this, 1500 watts, you may be able to get by with just one battery, particularly if it's also connected to a car that's running, because that will also get you some additional power. But unless the battery is fully charged, you probably won't get its full rating, so keep that in mind. Now for those of you who aren't familiar with batteries, I'm just going to give you a quick relative size comparison here between a few different battery types. Here in the foreground, I'm just going to put the 400 watt inverter so that you can compare battery sizes. Now as I said, a typical battery, a portable style battery, is only going to be able to supply about 1000 watts to an inverter. This here is a standard automotive battery. This happens to be a Group 78 battery. It's a GM style battery, and this is what they use in their larger vehicles. And this is about as big as car batteries come. They do come a little bit larger, but this is typically about the largest standard size that you'll encounter. And although this will supply around 1000 watts for an inverter, it will only do that for maybe 15 or 20 minutes, and then it'll no longer be able to supply power at that level. So it's also good to mention that an automotive style battery like this doesn't like to be cycled very deeply. Now if you're just going camping 4 times a year and you want to run an inverter, something like this is just fine. You can use your car battery for that. But if you're going to be cycling the battery more than that, I would recommend a deep cycle battery. Now I have here a deep cycle battery. This one weighs about 35 pounds, this one weighs about 40 pounds. This happens to be a Group 24 battery. It's only just slightly larger than this one, but it weighs more because it is a deep cycle battery. They use thicker plates on it. And this also is going to be able to supply around 1000 watts. Now, if you have 2000 watts you need to supply, well, you need 2 batteries. So now we have 2 deep cycle batteries over here. But those are Group 24, so they're pretty small batteries. A lot of you who go fishing, you might use a Group 27 battery, for example, and those are getting to be fairly unwieldy. They weigh about 60 pounds. This happens to be an X-side battery. These are lead calcium. These are lead antimony, if anybody cares about that sort of thing. So they are different chemistries, but this here will also be able to supply about 1000 watts to an inverter, and this will do it for quite a bit longer than your car battery. Again, if you want more juice, you need more batteries. 2 of them. So now we have a bank, if I connect these all up, a bank of 4 batteries, and this will be able to power about a 4000 watt inverter if I hook these all up in parallel. Now, if this seems like it's excessive just for powering an inverter, it is not. This really is what you need to get the job done. And in this video I'm going to be covering some fairly serious power inverters, and I just wanted to give you an idea of what kind of battery bank you'll need if you want to power something like this. It is not something you're going to be casually powering off of your car. First up on this set of 6 power inverters is the StatPower 1500 watt inverter. Now 1500 watts, I just covered 2 1500 watt inverters. You might be wondering, why am I covering a 3rd one? Well, because this one really is better than the other 2. And there's quite a few reasons for that. I'm not going to cover all of them. But first I want to cover the one thing I don't like about this inverter. These are the input power lugs for this inverter. and not sure if you can read it here in this light, but it says 10 to 15 volts, 200 amps max. Reverse polarity will damage unit. Well, yeah, that's true of just about any inverter. Typically blows the fuses in it. But take a look at these power lugs. They're only big enough to fit a 4-gauge wire into. 4-gauge is not going to do 200 amps. Now, I don't know what they were thinking when they designed it this way. I don't know if they just cheaped out or what was going on. But I'm really quite disgusted with this power connection here. Now, maybe they had some sort of cable with a special end that you would put in here. I'm not really quite sure what they were thinking, but that is the main negative about it. Other than that, this is a really nice inverter. First off, I should mention the name brand. This is a StatPower ProWatt 1500. Earlier, I had talked about a Xantrex ProWatt 600. StatPower and Xantrex are essentially the same company for practical purposes. I believe one bought the other a number of years ago. But StatPower always made good products, and this one is no exception. This is also sold under the name brand MotoMaster, which is distributed by Canadian Tire, which is kind of like our Harbor Freight here in the United States, except they chose to go with a reputable name brand, Xantrex, rather than Centec and Chicago Electric, like Harbor Freight did. So these are much better units, and this exact same unit here is actually sold as a MotoMaster 1750. Now, wait a minute. This is a 1500 watt inverter. Why would they sell it as a 1750, right? Well, that's because this really is more capable than most 1500 watt inverters are. They're more honest than a lot of the other manufacturers. This particular unit is capable of 1750 watts, 1750 watts, for about half an hour before it overheats at room temperature. And it's capable of, I think, 2000 watts for 5 or 10 minutes before it overheats. And I've tested the surge capability, and it is somewhere around 2000 to 2500 watts. So you can power quite a few loads off of this that you can't off of other 1500 watt inverters, and that's why I'm covering it in this video rather than the previous one. This is a significantly better inverter. This is also the first inverter that has bar graphs for volts and amps. This is a pretty old design. It's probably about 10 years old, so they don't have an LED or LCD display, but it gives you a nice indication of what your battery voltage and the amperage is. They have a good quality outlet on here. That doesn't sound like it's very important, but a lot of the others, they just get whatever the cheapest Chinese outlet that they can source, and they stuff it in their unit, and then they wear out and break and get hot, and who knows what else. This is actually a good one. The case itself is a heavy-duty anodized aluminum, very well made. The bottom plate is a heavy-gauge steel. If you look inside, the circuit board is coated, so it'll do well in a vehicle or on a boat. The fan in it is a decent quality fan. So overall, this thing is made pretty well. I purchased this inverter broken, just like most of the others that I've shown you, and I repaired it. I was told that this came out of an ambulance. The ambulance was equipped with a generator and an inverter as a backup. And I have no way of verifying this, but it seems pretty plausible because it had obviously had live power applied to the output outlets, and it was thoroughly fried. Both the input and the output stage had to be completely replaced, and now it works perfectly again. But there is one more feature about this inverter that I need to show you. This is the outlet end of the inverter, and if we flip it around, take a look at the other end, you'll notice this little punch-out, breakout plate here. And this is actually extremely important. This inverter is the first one that I've shown that is capable of being hardwired. All of the other ones that I've shown have what I like to call a live neutral configuration, where ground, neutral, and hot are all kind of tied together. I made a whole video about this, how not to connect an inverter to your power mains. If you're interested in that, go ahead and check it out. But this one actually can be hard tied to a wiring system, for example, a household wiring system. All of the other ones, you would need to run extension cords everywhere. So this is actually a very important feature for an inverter. It makes it a lot more flexible in how it can be used. And it is a more expensive way of making an inverter, however, it is also a much better way. This particular inverter isn't terribly efficient. It's not inefficient, but it's not as efficient as some of the newer ones. This technology is fairly old. Like I said, it's about 10 years old. However, this is a very nice inverter, and I would recommend it. If you can get a hold of the MotoMaster inverters that look exactly like this, I would recommend those over this one. Not because they're better, but because they sell for a lot less money. And they're essentially the same thing. I've shown you a couple of 1500 watt inverters, a 1750 watt inverter, but now it's time to step it up to 2000 watts with the Chicago Electric 2000 watt power inverter. Yeah, I know, it's yet another Chicago Electric product, but I promise this is the last one. At first glance, the box looks pretty much the same as the other Chicago Electric inverters. It even comes complete with all the same grammatical errors. Triple fans for maximum cooling, reduces overheating to increase maximum power use age time. I don't know what that means, but I know I want it. Alright, let's pull this thing out of the box and see what it looks like. Well, here's the inverter. It's a little bit beat up. I bought this one used. There's a story behind that. One thing I do want to mention is these lugs. I hate these lugs. These are so fat that you can't get any sort of cable around them. But they are better than what that Xantrex inverter came with that I just showed you. Now, if you look at this, it looks pretty familiar, doesn't it? Cooling fan over here, power connection, and take a look at that. Power switch on, off, a couple of LED bar graphs and outlets. This looks a lot like that StatPower 1500 watt inverter. But this is a clone in terms of its looks. They copied the design. However, they did not copy what's inside. What's inside is a copy of their other inverters, just slightly modified to be higher capability. Now I think it's kind of amusing with these Chicago Electric inverters that the advertising on the box is poorly written by somebody who doesn't speak English, yet the user manual is pretty well written. There actually aren't grammatical errors in here. It was written by an English speaker. Now I have no idea why you would spend your money to make a box that doesn't look right and then put a manual inside that nobody can see and actually spend time on it. But in any case, here on this page they say do not open the housing, no user serviceable components, internal parts may be electrified even when the unit is off and disconnected. That's probably worth mentioning. These inverters do have capacitors that stay charged if you don't discharge them, though. It's pretty easy to discharge them though. You just turn the inverter on with no battery connected and they discharge almost immediately. Then you can open it up safely. And there's also one other thing in here that I wanted to show you. Installation precautions. Do not install this inverter in a building's electrical system. It is a vehicular accessory, not designed to be safely used in a building's electrical system. Well, that is true. This inverter is not like the other one. It does not have an isolated neutral. You cannot put this in a hardwired configuration. You'd have to run extension cords and such. It has a live neutral. And that's one thing to mention. Even though this inverter looks a lot like that StatPower, it is not the same at all. Now I bought this inverter used and broken, just like most of the others that I'm showing you. And even though I bought this broken, I was quite disappointed when I received it, because it was disgusting. It was extremely dirty and very rusted up. It had obviously been used in a very corrosive environment. You can still see some rust damage here on these fans. However, I was able to replace a lot of the hardware on it to make it respectable again. I put on new knobs, changed the fan grate. The old one was so rusted up that it actually had pieces missing. Replaced the wing nuts, some of the screws on here, and it looks reasonably good again. Now, like I said, it was extremely dirty when I got it, so I had to clean it up. And how did I do that? Well, I put it in my dishwasher. That's right, I actually put that dirty SOB in my dishwasher. Did you know that dishwashers are great for cleaning dirty electronics? A lot of people don't know that. They actually work really great for it. Just disassemble it, remove the parts that you don't want to get wet, for example the fans, you have to take those out, and just load it in your dishwasher. And speaking of fans, let's take a look at those real quick. This inverter has 3 fans in a push-pull configuration. I really have no idea why these companies do that. It's a complete waste. But they have 2 fans here in the bottom blowing in, and 1 big fan in the back blowing out. So let's take a look at the fans that I removed. First, these 2 little ones. You might think that they'd use something really cheap. Well, these are the 2 fans that came out. They're seized up because their bearings are bad, corroded or whatnot. And these are actually PowerLogic fans. Now that surprised me. PowerLogic is a Taiwanese company. They make both good quality and just standard consumer grade fans. But they're a Taiwanese company that manufactures in China, and it's a decent brand name. I can't say anything bad about that. How about the main fan? Let's see, this is a Hui Tong? Yeah, I have no idea what this is, but it's crap. Alright, so I'll just load that in my dishwasher here. And, let's see, where's the electronic cycle? Well, it's not a pot or a pan, so normal, I guess? Man, I need a geekier dishwasher. There we go. That's more like it. Now, a lot of you are probably thinking, hey, wait a minute. We all know that electronics and water don't mix. Putting electronics in a dishwasher has got to be a bad idea. Well, actually, this is a really good way to clean a lot of different electronics. For example, computer keyboards and other things. Just put them in the dishwasher. It works great. And if it has a battery, make sure to remove the battery first, but common sense, right? Now, in the industry, this is actually how they do clean electronics. They put them through what is essentially a giant dishwasher. And they do use deionized water for this rather than tap water. In my house, I have soft water plumbed to my dishwasher. And I live in an area of the country that has a fairly high mineral content to the water, so that means that my dishwasher is filled with mildly brackish water. But I assure you, this will not harm any electronics. It's the heat of a dishwasher that may cause them some harm. Just make sure that it is thoroughly dry before you power it back up. Now, it's important to mention, if you do intend to use your dishwasher to clean electronics, do not use standard dishwasher detergent. This is far too aggressive and it harms certain components, particularly aluminum components. Now in this inverter, the case is made out of aluminum and the capacitors inside are made out of aluminum. And this is probably not the best idea to use. So use something different. You can use ordinary hand washing dishwasher detergent, such as what comes in bottles like this. However, these do foam quite aggressively. They do that for marketing purposes more than anything. And your dishwasher doesn't really like foam. It won't run properly if you put too much of this in, so only use 1 or 2 drops in your entire dishwasher and you can usually get by with it. Otherwise, if you have high efficiency washing machine detergent, you can put a little bit of that in instead. Some sort of detergent that doesn't foam. I just used this and it worked fine. The other standard industry way to clean electronics is with isopropyl alcohol. You can buy rubbing alcohol, which is isopropyl alcohol, at any pharmacy. And the reason I didn't use this is because it's a lot more work and it's a lot more expensive. Water's pretty much free, right? This does work quite well, though, at dissolving oils and other substances. And it can be reused also until it gets excessively dirty. But really, getting things clean is pretty difficult with it because you have to scrub it, and because everything is an odd shape, it's really not practical. But you can safely use isopropyl alcohol. Now, if you happen to run out of rubbing alcohol and you have a bottle of Smirnoff around, you might consider using that. However, don't do it because drinkable alcohol is ethanol, not isopropyl alcohol, and ethanol is very hard on quite a few different substances, one of them being rubber, and it will damage electronics. So do not use it. Only use isopropyl alcohol. There are also quite a few other substances you shouldn't use, standard garage type cleaners. Carbon choke cleaner, brake cleaner, engine degreaser, WD-40. None of these should be used on electronics. They're all hard on different things. And I could make a whole video about cleaning electronics, but I'm starting to get off track, so let's get back to the inverters. Now, before you use your dishwasher, you should probably ask your parents or your wife before you do this, because they may not like the idea of putting electronics in the same appliance that you use to clean the dishes that you eat off of. Or, alternately, just don't tell them. Hey honey, what have you been up to? I was just cleaning some old electronics. Oh. How'd you do that? I use soapy water. Alright, enough of that. Let's get back to the inverters. So over here I have the spec sheet that came with this unit. And a couple things to note. For one, they give you the fuse rating, 320 amps. Again, that is a very good sign. 320 amps is more than what's needed for 2000 watts, indicating that this probably has some surge capability. Not 4000, but some. And another thing to note here is the no load current. 2.4 amps. Wow, is that high. This thing will drain your batteries fast with no load. That's not what you want to see. The previous stat power unit was about 0.5 amps, no load. This is 2.4. They didn't put much effort into keeping that low. Efficiency is all pretty typical. And the battery voltage range is also quite good on this one. 15 volts plus or minus 0.5. I didn't test that. Hopefully it's closer to 15.5 than 15. But the low voltage alarm 10.5 and low voltage shutdown at 10 gives you plenty of room. Again, you want to have this low voltage shutdown as low as possible. Otherwise, when your batteries are partially discharged, the Pukert effect in your battery causes you to not be able to get much power out of them. So it's important to have that low. 10.5 is the minimum I would accept. 10 is better. So, my overall impressions of this inverter is that I'm fairly impressed. This is a Chicago Electric, which I associate with extremely cheap brand. However, it performs quite well. Aside from that no load draw of 2.4 amps, once you actually start drawing some load on it, it is reasonably efficient. There's not really a problem that way. And also, it is advertised as 2,000 watts. However, it does about 2,200 watts, and it doesn't get too warm while doing it either. And testing the surge capability, it's a little over 3,000 watts. That is only for between half a second and 1 second, but that's long enough to get most loads started, including air compressors. So, this really is a pretty good inverter. I would actually recommend this one. Unfortunately, because it is Chicago Electric, and they reserve the right to change their product at any time, you never really know what you're getting. This particular one is good. The next one you buy may or may not be. In any case, I like this one. Well, I intended to cover the remaining 6 inverters in this video. However, it's been 20 minutes and I only made it through 2. So what I'm going to do is split this up again, and next time we'll cover the remaining 4 inverters as we continue to crank up that power dial. Thanks for watching.